Hello everybody and welcome to my channel. In this quick video called Data Analytics Computing Follow Along Linear Regression with Python, I will go through this script line by line explaining how to perform linear regression with Python. I'm currently a graduate student in Data Analytics Engineering at George Mason University. I am doing this video primarily for students that may be struggling with how to perform linear regression. I will be focusing on the computing part, and I will touch upon some mathematical foundations, some programming concepts, and some statistical inference. However, I will leave in the description way better resources to follow along in this short video. First of all, I will assume that you have some familiarity with Python and Spider. I'm using Spider 5.1.5 with IPython 8.4.0. I will leave links to how to install Spider and Anaconda if you don't have it yet. In any case, to start with, we can just do this. This button here, the play button, will just execute the whole script. And as you can see here, it's not very useful because everything happened, but we don't know what happened. Therefore, I will go ahead and start everything just line by line instead. I will remove everything that happened, and I will also remove this plot. So let's start here. This is a comment. This will not be executed, and you can double check it. If I just do ctrl enter, that is a shortcut for this one here, that is running the selection, I will not get anything here. I do this to put notes basically for this video. You will also have the script available in the description. The first thing we're going to do is import these three packages here. A package is a piece of software that you can use and somebody else build. In this case, we need pandas, sklearn linear model, and matplotlib pyplot. I will not go into the details about why we need these packages, but we need them for the model to run. Importantly, in sklearn, the linear regression algorithm is actually written already. We don't need to reinvent the wheel, we can use it from here. If you don't have these packages, you will need to install them. You can install them with the following commands on the console. That it's over here, or you can do it through your terminal. There is a couple of ways to install those packages in your Python environment. This print function here, as you will notice it, is a double check for me, especially as you saw before here in the console. It allowed me to run the whole thing and see that everything was executed correctly. Now, we will also import this data set. This data set is a Google data set that has the Google stock for the last years. You can use it using this function, pd read Excel. You might recognize pd read CSV from other courses or other experience with Python. This function basically takes this file path and this sheet, where is the sheet that you want to import in. In our case, just by default, that's the name of that. Now, we could do this and just run this path. This will give us the data set here. Now, why do we have this? A very basic programming concept is that we can assign this thing to a variable. We call this a variable, and actually here we can see the variable explorer. If I do this, notice the difference. Instead of doing this and putting to the console the data set here, I'm assigning it to the Google VF. Now, if I do this, it's going to return me the Google data set that I just imported from this Excel document. Why do we want this? And here you can see it's a data frame. We want this as a shortcut. We can use this and reuse it over and over again. Instead of importing this all the time, it's going to keep a copy here. A good analogy I want to use, if you're not familiar with this, is having a file instead of writing in Word, for example, or PowerPoint a presentation, and you need to do it over and over again every single time. You can just save it as a file and play around with it later on in your file explorer. This is a very similar concept to that. We can use this method called shape to do a quick exploration it returns you the dimensions of this data frame. You can see here we have 5 different columns, 7 different columns, and we have 106 rows. You also get this here. We also have this method called columns. These will return us the actual names of the columns, as you can see here. And head will return us the first values, the first 5 values by default, but you can actually customize it to be more or less depending on your preferences. Now, going into actual linear regression, we will use first change percentage as our X variable, and the average volume as our Y variable. If you are familiar with this terminology, you know what I mean. If not, this is also called the independent variable and the dependent variable, or the predictor and the prediction variables, depending on your terminology. What these brackets do is basically slicing it, as you can see here, and getting the data ready for scikit-learn's convention. We will import the linear regression model from sklearn. What is this? This is basically saying, give me the model that is already previewed in sklearn that we don't need to code ourselves, and assign it to this variable that is called linear model. Something important here, this is the actual name of the variable of the function that we're using from scikit-learn. This is just an arbitrary name. It could be reg model, LM is very popular, or any kind of name that you wanted to use. Later on, you will see that I actually create a second one, and they are totally different. We can use this method called fit from sklearn to very simply take the predictor and the prediction, and then we will use this model here. Then we can get the score. You may also know the score as the R-squared value. This R-squared value is 0.02. That is very bad in this case of models because it goes all the way from 0 to 1. As you can see, it's very close to 0. Without going that much into statistics here, we may want to use another variable. Therefore, we can do this. Notice here that we already use X as the variable name. Now, if we are using X again with the Google DF, we are going to override X. So if we invoke X again, you are going to have now the closed variable. You don't have anymore the change percentage column that you had here. Now you have the closed. Now we are going to create another linear regression model just to keep the old one there, just in case. As you can see here, it did not override the old one. We actually have a different linear regression model called linear model 2. We can do the same thing that we did before. We're going to train it, but now X is not change percentage. X is now closed. We're going to fit it, and then we're going to get this score. It's around 0.15. It's not the best score ever, but it will work for this demonstration. We can calculate the predictions for the model, and we will go a little bit more in detail later on. As you can see here, we have gotten the predictions for it. And again, this is just a shortcut. We can do this, Google predictions. And you can see here that we have all the predictions that were calculated there with a lot of decimal points. We are going to plot the results of the second regression just because I find this pretty valuable just to show what's the relationship here. These 4 lines here are just for aesthetic purposes. These just put the ticket labels formats. This also gets the X label and puts the closing price, average volume, and this adds a title. The important part are these 3. This one takes the X variable that you had over here, and again, that will be closed. The Y variable that we have over here, and then it's going to color them with blue into a scatter plot. Then we're also going to plot the X variable again, but we're going to take the Google predictions and then make a line with the color black. And this just shows the plot. So if I run all these lines together, we are going to get this. And this is the basis of what we mean by linear regression. As you can see here, you get a line here that is going through the points, minimizing the distances between the line itself and each single point here. If you are in a statistics class again, you may know this by the ordinary least squares regression. Notice how we use a scatter plot to visualize the model. This is a condition of linear regression. Both of your variables that you're using need to be continuous and numeric for this to work. Also, this is the most basic approach for linear regression. You could do multiple linear regression where you're using more than one X, and it's way more complicated to actually visualize than this simple line going through these points. But this is the basis of all linear regression models. And this is the core of how to build it on Python. Notice this point on the far left. This here is what's called an outlier. You don't need really to know a lot of details about this for this video, but just to know that if we were doing more rigorous statistical inference from this model, we will be very worried about these outliers because linear regression is pretty affected by outliers like these, points that are very far away from the general trend here. This linear model has an intercept and a coefficient. You may know it as a slope because this is a line. It's a line with slope as well. We can take it from this very useful method from scikit-learn and create it. And now we can call that. Notice how I can just highlight this and play here, and that's my coefficient there. We can also take the intercept. I will do the same thing with the intercept. And I can also display that the intercept has been saved here. Perfect. And as you can see, we can also do some more fancy stuff with Python with the print function. For example, this f here, without going to a lot of details, allows me to put variables inside text. So I can do this. If I run this line, I get the number from the intercept and the coefficient here, plus the x here that I put it there. This will be the formula of our regression line. Now, let's look at the predictions once more. Instead of plotting the regression line, we're actually going to plot the predictions of the model. And again, these are just for aesthetic purposes. What matters here is the scatter plot here and the predictions being plotted here as well. So we're going to do the same thing. The original values are going to be in blue, but the predictions are going to be in red. Here you can see what's the matter. All the points need to be in the regression line. That's what linear regression does. It allows us to have all the points as a prediction, but it will do it through the regression line. If you're familiar with functions, you're basically taking whatever x value you have here, in this case, again, the closing price, you're putting it into this formula here, and you're getting these points here. That is why it's called linear regression. You're making a line. That line will predict every single point through the line. Finally, one advantage of linear regression, especially considered with other more complicated models, is that it can predict points that are outside of the linear range. See how in this range we go from 20 to more or less 145. What if we want to predict the volume for $200 closing price for the wood stock? We will do this. We take the formula, that is the intercept, plus the coefficient multiplied by the x value. And we can actually get that too. As you can see here, this will be the volume over here for this value. And if we follow the regression line with our eyes here, it will be somewhere around here. That's pretty in line with the regression line. For a sake of the matters, it needs to go through the regression line. There are way more complicated approaches and way more elaboration that you can do through linear regression. And again, it's one of the simplest predictive algorithms over there, or machine learning algorithm, if you want to call it that way. It really depends on your terminology, or statistical models if you use another terminology. This video is just a short introduction to the computing part of it. If you're not that familiar with Python, I would recommend you to just go through the code that, again, I will make available on the description of the video and follow through the logic of the code. Thank you. I appreciate your attention, and I hope that this video was useful. Let me know in the comments. You can also subscribe and leave a like. Thank you very much. I hope you have a good day.